Hello, everyone. Welcome to another Teach Kelvin Your Thing session. Today, I'm going to be learning why the world needs a framework called Qwik. And my teacher for today is Miško Hevery. How you doing, Miško?
Hey, how's it going? Happy to be here. This
Yeah,
should be a lot of fun.
yeah, I'm really excited to get into the why of Qwik. So before we do that, could we have an introduction about who Miško is, what you've done in the past, and what you're currently doing?
Yeah.
Mm.
So, hi, my name is Miško Hevery. I'm a CTO at Builder.io. Builder.io is a headless visual CMS system. And we are also working on a couple of cool technologies. One of them is Qwik, which we're going to talk about today. Partytown is another one. And in previous life, I worked on this thing called Angular and AngularJS. Maybe it had something to do with Karma. And I had a whole bunch of popular talks on testability back in the day before the kind of I got into the frameworks world. So yeah, that's a quick about me.
Yeah, awesome. So I think you kind of downplay working on Angular because for my research, you made Angular and AngularJS. Am I
Yes.
right? Yeah.
Yeah, those are my projects.
Oh,
And so now,
yeah. That's
yes.
amazing. That's amazing. Really nice having you here. So the business of today is Qwik. So
hmm
could we dive into that from the perspective of what is the fundamental problem Qwik is
hmm
trying to solve? Yeah.
Yeah. So let's jump into it. I think
Mhm.
you've been on many websites, right, where you navigate with your browser, especially on a mobile device. You see the page, you're like, great, that's exactly what I want. I want to
Mhm.
click on this button over here, and guess what? Nothing happens, and nothing happens for many, many seconds. And what's happening during the time is that you're either downloading huge amounts of JavaScript,
Mhm.
or you are waiting for the JavaScript to execute and do this thing we call hydration, basically
Okay.
to make the page interactive. And this is a problem, and this is especially a problem on slower networks and on mobile devices. And there is a lot of evidence that basically shows that if your website is slow, if it's hard for the user to get their work done, people will just leave, right? And so that affects the bottom line. It affects the conversion rates. When the conversion rates have to do with money, then it affects the sales the company has. And so companies like Amazon and Google and eBay, that live and die by these things, they spend huge amounts of resources to making sure that their sites are as fast as possible, right? Part of the reason why everybody uses Google, right, is because it's both accurate, but also it's very fast, right? Like
Yeah.
that when you navigate to Google, it's just you're going to get a result instantly. And if Google would start being slow, right,
Mhm.
I'm sure people would switch to an alternative search engine because, on the end of the day, they really just want the result as fast as possible. And so, speed is kind of the key. And I think we are in the world where we understand that speed is important, but we are failing to really deliver on that. Like, with the exception of few companies like Amazon, eBay, and Google, vast majority of us are failing to deliver on the speed. And it's such a big problem that Google has dedicated quite a lot of resources to building this thing called Google Page Speed and Core Web Vitals,
Mhm.
where they're actually monitoring, like, collecting data and providing that information to both the developers, but also using that information to for search rankings, right? Because humans are funny creatures. When we navigate to a site that's slow, we have a lower opinion about that site than if we navigate to a site that's very responsive and crisp, right?
Mhm.
So humans will make secondary opinions about the quality of your website purely from its performance characteristics. And
Yeah.
so there's a lot of basically evidence that says, like, speed matters. Like, you
Mhm.
want to get a fast possible site as you can.
Yeah. That's when you mentioned the speed of Google, I sort of just had a recall of something that I experienced quite recently. So there is this alternative to Google that came out. So they were pitching privacy and stuff. I think the name is Niva, right? So what happened was I tried using Niva, and even though I like the UI and everything, but the speed alone of google.com and the speed of Niva, I don't know. I had like I could literally see that it was significant. So Google was quite fast. Never took maybe 2 seconds to return search results, and that threw me off. And I actually uninstalled the app. So you're right, speed really does matter. Even if we might say, maybe just a few seconds, but no. So if your users can perceive that delay, it just doesn't feel right to them, right?
That's right. That's right.
Yeah. Yeah. Cool.
And we spend a lot of time actually worrying about speed in terms of these performance metrics, right? Like I'm sure you've seen many popular sites that look at different frameworks and see how
Mm-hmm.
fast they render.
Yeah.
But I think that's missing the point, right? I think what these tests measure are things like, how long does it take to insert 1,000 items into a list?
Okay.
But that's not really what the real world is about. Like these performance metrics make a couple of assumptions. First of all, they make an assumption that the code for this test is already downloaded in a browser.
Okay.
They make another assumption that the code has been executed many times and the jitter is already warmed up, so that
Mm-hmm.
you're not in the interpretive mode, you're in the JIT mode. And they really don't even take painting into account. They really are just looking at how long does it take to insert all of these elements into the DOM. And if you compare this to actually what's happening, like let's just take Google as an example, right? When you go use Google, at no point are you inserting 1,000 items into anywhere,
Mm-hmm.
right? Like no
Yeah.
interaction with Google will do that for you, right? And the same thing if you go to Amazon or eBay or any other website. Like when you navigate to these websites and you click, when the user interact with the site, at no point are we actually inserting 1,000 items anywhere. It's always like, oh, add this item to the shopping cart. Great, like insert one item into the shopping cart, right? That's the kind of performance we're talking about. And so while these benchmarks measure how fast are we at like updating the DOM,
Mm-hmm.
it misses the point because that's not the problem. The problem isn't that it takes too long when I click on add to shopping cart to add an item to the shopping cart. The problem is it takes too long before I can click the button,
Ah.
right?
Yeah.
Right. So the issue isn't that like it takes too long to process it. The issue is it takes too long before I can click it.
Yeah.
And so I am going to argue that we're kind of focusing on the wrong thing.
Okay.
And instead, we should really start focusing about how long before the site becomes interactive, right? So the real world benchmark is you navigate to the site,
Mm-hmm.
you don't have JavaScript, so you have to download JavaScript. You don't have the jitter isn't warmed up, so you're running in interpretive mode,
Mm-hmm.
and then go click a button and see how long it takes for the button to be added into the shopping cart, right? The item to be added to the shopping cart.
Mm-hmm.
And I think that's a much more realistic scenario that people are faced with.
Yeah, that's
So I
true.
think it's a bit of an education thing that I think we should like stop focusing on it. The other thing people are oftentimes over focused on this performance benchmarks is they think like, oh, this framework is 10% or 20% faster than this other framework, and they assume that that means that their application is going to be 10% faster, and that's
Mm-hmm.
just not the case.
Okay.
There's so many other things that go into the performance that a 10% improvement in speed is just going to have no noticeable effect for the end user. And again, like the thing to focus on is not necessarily how fast we can render, but how long it takes before we can interact with something.
Okay. Yeah, that makes total sense. Because
Yeah.
okay,
Mhm.
go ahead.
No, I was just gonna say, like,
Mm-hmm.
the how long it takes to interact with something really comes down to there's only really one metric, and that is like how much JavaScript do I have to download and execute, right?
Yeah.
The less code I have to download and the less code I have to execute, the faster my interaction will be with that particular button.
Yeah, true. That's true. Because maybe I don't know. Maybe I'm hypersensitive these days because, like, I visited a conference website like some other day, and I clicked on the speakers page. So I think the website is sort of like an SPA, maybe,
Mhm.
or maybe it was hydrating. So click on the speakers page. It took like 3 seconds, and nothing was happening. I was like, okay, did I break it? Then it loads, and I was wow, that was too slow because at that time I thought something was wrong with the website because there
Mhm.
was no feedback. It was just too slow. And I think probably it's because of hydration, like you said. So how does how do Qwik tackle that hydration problem? Is Qwik doing hydration, or is there a new concept that Qwik is implying?
Yeah, there's definitely new
Yeah,
concepts. So
yeah.
let's talk about hydration first,
Mm-hmm.
and then we can talk about how Qwik is different. So when you get a page that's pre-rendered on a server, right? And
Okay.
so you see a page that is a button over there, and you want to click on the button. The problem is that the browser has no listener attached to the button, right? So if you click on it, the browser is like, "Yeah, we clicked on it. Good job." Like, I don't know what to do,
Yeah.
right? So we need a way of figuring out how to attaching behavior to the button, right?
Okay.
And so the way this is done is we build our button using our framework,
Mm-hmm.
and for the framework to be able to attach the listener, it has to kind of build up the state of the system, right? The information about the application, right? It needs to know where are the component boundaries, what state different components have, where are the buttons, where are the listeners, or whether it's a click listener, whether it's a mouse move listener, whether it's what have you, the kind of a listeners on it, right? So
Yeah.
the framework needs to have a lot of information before it can do any of these things. And so the question then becomes like, well, how is the framework supposed to know what should happen when you click on this button, right?
Mm-hmm.
And so the way framework knows is it says, well, I will execute your application from the root all the way from the beginning. And as I'm executing the application, I will visit every single component. And as I visit every single component, I will render every single template. And as I'm rendering the templates, I will collect information about where are the listeners, right? Where do I have to attach the listeners? And so
Mm.
what happens is you navigate to a page, you see the page because it was rendered on a server. And now the framework kind of downloads and wakes up and says, okay, let me download the whole application. Let me start at the root of the application and visit every single component. And as I'm visiting component, I'm going to collect information about where the listeners are. And when I'm finished with kind of visiting the whole application, then I can do something called reconciliation, where I actually compare the information that the components give me about what the DOM should look like against what the DOM actually looks like. And hopefully, the reconciliation will produce no updates, right? Or hopefully, the two are identical.
Mm-hmm.
But in the process of doing the reconciliation, I am able to attach listeners to the DOM, and that's how I've made the application interactive, right? So you
Yeah.
navigate to a page, you see a button, you cannot click the button because it's not the system hasn't been hydrated. The browser downloads the framework. The framework downloads the application. The framework executes the application. In the process of running the application, the framework learns about the boundaries of where the components are, where the buttons are, where the listeners are, and so on and so forth. Once it collects all that information, it reconciles the actual DOM structure against what it thinks it should be. And in the process of reconciliation, it attaches the listener. And it's at that point when the listener is attached that you can go and click on the button and have behavior,
Mm.
right? And the problem is that that's a huge amount of work. Like it's
Yeah.
huge amount of work in terms of both just the computation, but even worse, it's a huge amount of work in terms of actual, both in terms of the actual execution and the actual amount of JavaScript that the system has to download. And really, all of this work is done to recover the information about where are the listeners, right?
Yeah.
And you can think of that as kind of the boot up equivalent of an application, right? Like you come to a site and the site basically has to boot up, right?
Mm-hmm.
That's the equivalent operation that has to happen. You have to just download and do all this work. And so the more complicated your website becomes, the more JavaScript you have to download, the more code you have to execute, and so on and so forth. And so the slower and slower the website becomes. And we say that that's like O of N, meaning like the more complicated that particular page becomes, the slower the startup performance is going to be, right? So, you might start up with a simple button and the application is fast on startup. And then you add menu system, you make it a little bit slower. Then you add product details, make it a little bit slower. Then you add the reviews, the product reviews on the page, and makes it even slower, right? And as you're adding more and more features to the page, the page is just slowly becoming slower and slower and slower because you are incrementally adding the amount of JavaScript you're downloading, and you're incrementally adding the amount of JavaScript that has to be executed. You're incrementally adding the amount of listeners that have to be attached to the DOM, and it's like the death by a thousand cuts, and it just gets slower and slower and slower until you get to the point where, like, yeah, I have this application that does all these amazing things, but the startup performance is just not very good at it.
Yeah.
So, now you can ask yourself, like, well, how is Qwik different, right? Like,
Mhm.
well, before I kind of go talk to Qwik, I want to make a point here
Okay.
that all of the existing frameworks, right, whether it's Angular, React, Vue, Svelte, Solid, whatever your favorite framework has, they all have this behavior. They all work this way. So they all have all of these deficiencies, problems, or like these challenges that you have to kind of deal with, right? And I call all these frameworks replayable. And the reason I use the word replayable is because at the server, when we were doing the pre-rendering of the page, the application had to boot up. Like, there was no choice; we had to boot up the application, right?
Mhm.
And then we serialized everything, but the framework knew where the boundaries are, where the listeners are, where all the information was, but it was thrown away. We didn't serialize that information. We just, like, the server just, like, threw it away. And then when you get to the client has to recover this missing information. And the way it recovers the information is by redoing everything that the server just did, right? The client replays the steps that the server just did in order to recover the information that the server just had so that it can continue execution, right?
Mhm.
So this is why I call it a replayable framework. Now, Qwik is different because Qwik is what I call resumable. And what I mean by that is that, again, we start with server-side pre-rendering, but instead of once the server-side rendering runs, we collect all the information about where the listeners are, where the component boundaries are, where the reactivity is, and all of that information gets serialized into the HTML. So when the framework wakes up in the client, it doesn't have to do anything, right? It just deserializes the JSON that provides all the information. And as a result, the framework doesn't have to re-execute the application or even download the application for that matter, right? If you don't have to execute it, then you don't have to download it.
Mhm.
And it knows where the listeners are. It knows what the state of the system is. It understands the reactivity. So all the information is basically recovered for the framework. And so when the framework wakes up on the client, there is nothing for it to do, like literally zero amount of work. And that's what makes it resumable, right? But it also is cool because it means that as the application gets more and more complicated, the amount of work that has to be done on the client is always zero, right? Like, you add a menu, great, good job. Like, I still don't have to do anything because I can just resume. You added a comment section on the bottom, great, good job. Like, I don't have to do anything. Qwik doesn't have to do anything on the client to restart the application. Like, the application becomes more and more complicated, the amount of work that the client has to do to kind of wake up is constant. And this is why we call it the O of one framework, right? Because there is no additional work that has to happen on a client to kind of get the whole thing going. And that's what makes it resumable, right? And so Qwik has this really strange property that when you navigate to a page, Qwik has to execute essentially zero amount of JavaScript. There is a teeny tiny quick loader that has to execute to kind of get the whole thing going. It's only about a kilobyte. But other than that, like, there's no JavaScript to execute. And because there's no JavaScript to execute, there's also no JavaScript to download. And because nothing gets downloaded, nothing gets executed, your site is immediately essentially interactive. Immediately you can go and click on a button. And when you click on a button, we then execute only the JavaScript that's absolutely necessary. Now, at this point, I'm sure some of the people in the audience are like, oh, well, doesn't it make the click slow? Like, isn't it like now you just move the problem to a different location?
Yeah.
Well, the answer is no, and for a couple of reasons. So, first of
Okay.
all, the amount of JavaScript that you have to execute is way, way less. So, let's say we take a buy button as an example, right?
Mhm.
In hydration world, you have to download the whole application because you have to find all of the listeners and you have to reconcile everything. So the whole application has to get downloaded, executed, and reconciled at the beginning.
Okay.
In the case of a Qwik, the only thing that we need to download is the listener, the piece of code associated with the buy button click listener, right? Because that's the only piece of code that you need to have present. You don't need the code associated with the menu system, or the code associated with the product details, or the code associated with the product review, because the user didn't interact with any of those things. Like, the only thing that they interacted with the buy button. So only the buy button code has to be downloaded. And of course, the buy button will probably insert an item into the shopping cart. And so now the framework has to understand, like, oh, there is a reactivity relationship between me inserting an item inside of the shopping cart and me having to go and re-render the shopping cart.
Mm-hmm.
And so at this point, the framework has to download just the shopping cart, nothing else, right? It doesn't have to download the menus or the product details or the product reviews, just the shopping cart piece of code, and has to re-render the shopping cart because now we have an extra item inside of the shopping cart. So the amount of code that has to be downloaded and executed are orders of magnitude less, way, way, way less. But you can still say, like, yeah, but like you still have to download the code. And so,
Mm-hmm.
like, wouldn't there be a delay waiting for the download? And
Yeah.
so the answer is yes, there would be a delay, except that we have prefetching. So the way it actually works is that you navigate to a page, and one of the things that we do is, in a separate thread, in a service worker, right? So it's a separate thread, not affecting the main thread of the execution of the browser. In
Okay.
a separate thread, we start prefetching the code of possible ways to interact with it. So, for example, we can look at the HTML and see, like, oh, there is click listeners in these locations, and therefore it is possible for the user to interact with the page with these ways. And so now let's go and start immediately prefetching just those pieces. And again, keep in mind that the listeners are a tiny fraction of the overall application. And so, even though we're eagerly downloading code, we are not, one, executing it. And two, the code we're downloading is a small fraction of the overall application. So, let's say we only have to download 1/10 of the code. And on top of that, we don't have to execute it, right? So it's huge wins, because you can go and just download a smaller chunk of what you actually need, and do less work. So, for example, example of code that will never probably have to be downloaded is the code that renders the layout of the page, right? Like, during the lifetime of you navigating to the application, the layout of the application never changes. There's a menu on the top, product in the middle, the reviews on the bottom, right? That never changes. And so, because you can never re-render that, you should never ever have to download that code to the client, because why would you run this code on the client?
Yeah.
But in the case of a hydration, that code has to download, because that's how we get from the root of the component to the children, right? We have to go and visit every single component, because we don't know. There could be a listener there. There could be something that is actually relevant. And so we have to download everything. Whereas Qwik has already did all that stuff on a server, and now it has just information like, oh, that component is static. That never changes. So, like, don't bother even shipping it to the client. And so you end up with a lot less code being downloaded to the client, and none of that code has to be eagerly executed. All of the code only executes, well, not all of the code, just a small portion of the code that you download only executes when you actually do some navigation and some operation, right?
Mm-hmm.
So, sorry, that was me a lot of talking, but like,
Yeah.
basically, basically what we're starting with is, like, the problem is, browser is overwhelmed by the amount of JavaScript that has to be downloaded and executed, right? That's the problem we're starting from.
Yeah.
And the reason why it's overwhelmed by the amount of JavaScript that's being downloaded and executed is that the way the existing frameworks recover their state, right? And what I mean by recover is, like, the way they learn about what the application should do is by eagerly executing the application on startup. And that execution basically is the source of the problem. It's the thing that makes everything slow, because you are forcing the system to eagerly download and execute code. The observation that Qwik had was like, well, you already had all that information at the server.
Yeah.
So if you can figure out how to store that information in the HTML, then when you get to the client, then you can reason about the system without actually any code being present, right?
Yeah.
What I mean by reason is that the system can say like, oh, there is a shopping cart, and if somebody modifies the store that's associated with the shopping cart, then I know that I will have to download the shopping cart, right? But if nobody modified the shopping cart, then I know I don't have to do this, right?
Yeah.
And so there are many different stores in the system, and the framework understands the relationship. Like, oh, this store is used in this rendering of this component, and this store is used in this component, and this one and this, and so on and so forth. So when finally somebody does modify some store, the system can be like very surgical about like, oh, you modified the shopping cart, therefore I know I have to download the shopping cart and process the shopping cart. But I also know that you didn't modify the menu or the review or the product itself, and therefore I know I don't have to download any of that stuff or execute any of that stuff,
Mm. Interesting.
right? So now the updates or the cost of update is proportional to the complexity of the operation you're performing rather than proportional to the complexity of the page, right?
Okay.
It doesn't matter how complicated your page becomes. What matters is like, well, how complicated is adding an item to the shopping cart? Well, that's not very complicated. That's pretty straightforward, right? And
Hmm.
so you're paying your cost, your complexity is has to do with like how complicated it is to add an item to the shopping cart, not with like, well, how many other things are on this page? Do you have menu? Do you have reviews? Do you have like whatever else happens to be on this particular page, right?
Mm. Interesting. Yeah, I think I understand it. So in hydration land, like the frameworks that support hydration, when the page loads, even though maybe it was server side rendered and they've already rendered most of the pages, but for the page to be interactive, they have to redo everything they did in the server side to render those pages on the client, which is definitely going to take time. So if there are more complex things in the application, it's going to take more time than if it was a simple page. But with the quick approach of resuming, you don't redo the work that's been done in the server. You kind of smartly wait for possible interactivity, and
Hmm.
you load only the JavaScript needed for those spots in the app
Hmm. Hmm.
without loading other JavaScript that is not going to be needed at the time. That is brilliant. So I kind of think, okay, how would you achieve this high level? So there is the entire JavaScript of the app, but you are just taking pieces that the user is going to interact with. How do you do that at a high level?
Yeah,
Yeah.
that's the complicated bit.
Yeah.
Maybe some examples might be useful. What do you
Uh,
think? Should
uh,
we do some examples?
yeah, let's do that. Switching over now.
Yes.
Mhm. Oh, we're there.
All right.
Mhm.
So here is a let me see. How's the font? Is it big enough?
Yeah, it is. It is big
So here,
enough.
okay. So here is a an application that is very simple. All it is we can click on the count and increment the number, right?
Mm-hmm.
And we also have a button we can click alert, and it's prints out the alert. So it's a pretty simple app. Now, this app is actually part of a bigger app. So you can see that there's a header, there's a footer, and so on and so forth. And actually, if you look at the HTML, you see that every time you see these QV
Mm-hmm.
comments, that's actually a separate component. So there's quite a lot of components here. And of course, we have our div in here, and we have, let's see, where is it? Let me get the button here. We have more components in here. So I don't know how many components are on this page, but my guess is something like 20 components are actually involved in rendering this particular page. And mainly not because the counter itself is complicated, but mainly just to set up the header and the footer and kind of the
Yeah.
the, the, the chrome around the app, right?
Mm-hmm.
Now, the thing I wanted to show you is that when you go to Network tab, and let me refresh this. So now this is running in a dev mode, and in the dev mode we use a technology called Vite. Vite only is present in the dev mode. It doesn't work in it's not present in a production environment. So what I'm going to do is I'm going to filter out the Vite, and I'm going to hide it, saying like, you know what? Yeah, I know it's there, but this JavaScript it doesn't count because in production it's not going to be here. And what I want to show you is that when you navigate to this page, there's no JavaScript in here whatsoever.
Mm-hmm.
And then when I click a button such as alert, obviously the alert happens, but notice what you see here is that the code downloaded for the alert. Now, what's unique about it is if I click on it, notice that the only thing that downloaded is really the alert, nothing else. Remember, I said there's like 20 different components on this page,
Yeah.
and there's a lot more stuff here. But yet the system was like, yeah, but really the only thing you need is just this alert and nothing else, right? And so the question is, well, how does this work? So let's go over to the counter here. And so this is a counter example here. And we create a component. We have our store, which is the count. And in here, we basically have our button. So here's our button. And this button says, when you click me, do an alert. This particular component has a subcomponent. It's really just for demonstration purposes, like it wouldn't have to be. So you can just kind of ignore this. I really only want you to focus on the button in here. So if you think about it, like what's happening is the system can take this JavaScript right here and download it as a separate thing. And that's kind of strange because like what actually is happening is we basically do something like this. Right? We have extracted this function from here and moved it into a location that you can see inside of the file. And then somehow this is not even in the same file. This is actually in a completely separate file because, oops, this is the Vite hot module reloading. Let me just undo this. When the system downloads it, right, it just downloads that file and nothing else. Why is it not showing? Oh, because of the alert.
Hmm.
Um, it just downloads the whole thing. So the magical bit of Qwik is that it can take code that you can see over here and it can do a transformation to the code such that it can just download that one specific thing and nothing else.
Wow.
Okay. Now,
Yeah.
that's the simple case. So before we actually go deeper and I show you more complicated cases, let's actually focus on this alert button for a second. And this is what I mean by serializing the state. Notice there is a on click and it has a URL. Again, this URL is long URL because we're in a Vite mode for development purposes, and these are
Hmm.
friendly URLs. In production, you'll see a short URLs in here. And what this basically says is that if you click on this button, you need to go download this file. And inside of this file, there is this symbol that's being exported. And so that's the symbol you need to execute, right? So if I click alert, and I go to network, what I see is that this file here, right? This file is going to show me. Well, it's kind of hard to see here. Let's see headers. Here we go. So this is the URL, right? This is the file that it asked us to download,
Hmm.
right? And this file exported this symbol that you see over here,
Yeah.
right? And so that's the symbol that it's actually getting, and so it knows that because it can look over here. And so what happens here is when you click on this button, the browser bubbles the event, right? The event goes up, 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 up. And finally, it's intercepted by this quick loader. This is the magical piece of code. It's about a kilobyte that knows how to do that. And because it's so small, we actually inline it directly into the HTML so that the browser doesn't have to make another request. It's a pretty small piece of code. When it's minified, it's about a kilobyte, right?
Yeah.
And so it's inlined directly in there. And this piece of code just tells it like, oh yeah, by the way, you're going to have to listen for click events because click events is a possible thing that can happen. So pay attention to click events. And so
Nice.
that's kind of how it works. You click on this, it bubbles up, the quick loader intercepts it, and then a quick loader goes and looks at this URL and says, I need to download this piece of code and then execute that function inside of that piece of code. Okay, so that makes sense. So let's look at a more complicated case. So uh, I think it's pretty straightforward how this works. But this one is actually a lot more complicated. Let me show you this. So let's say we do the same exact operation that we just did. We say export const foo equals this thing. And notice what happens. The system's like, yeah, but what is this store? Like, I don't know what store is.
Yeah.
Okay? Because the store came from here. right?
Mhm.
And when you do the transformation, when you pull this thing out, um, you can't do that, right? Because this is a function, but this thing here, which we extracted, that's a closure.
Okay.
We have closed over a variable. In this case, we closed over the store. And
Mhm.
so this is where things break down, because it means like, oh, in order for you to create this closure that I need to execute when you click on a button, I first need to execute the component, because the component needs to create the store. And guess what? In order to execute that component, I might need references to the parent component, which then in turn needs references to parent. And so pretty soon you realize, like, in order to get this closure, I pretty much have to have the whole application, right?
Mm.
So how does Qwik deal with that? So let me undo this. And let's go back here. And now let's click on the increment. And the thing to notice is that when you clicked on the increment, let me refresh this again. When we clicked on the increment, we downloaded just our code, which is these two lines, right? Click increment and count plus plus, that basically came from here.
Okay.
Bit that recovers the information of the store, and that allows us to be able to create the closure without having the component present.
Mm.
So let's kind of follow through what's happening, right? So we clicked on this button again. If we go here, you see that we have the URL and the symbol that needs to be downloaded and executed. But we have an additional piece of information here. And this additional piece of information, which case talks about store 0, is the bit that's needed to recover the store, right? So that basically says, oh, by the way, that function is going to want to recover the state of the system. And that state can be found at some location, in this case, location 0, because it's a very, very simple example.
Yeah.
Okay. And that allows us to download just the button associated with here and nothing else. Now, once this downloads, the next thing we have to download is the framework itself, right? In this particular case, we have to have that. Now, notice what happened originally. Let's go do this again. When I clicked alert, we only had to download the handler itself, but no framework. The framework was actually unnecessary in this particular case because this doesn't do anything interesting. But when I go to the increment, obviously I have to start with the listener,
Mhm.
but now I also have to download the framework because I'm going to have to re-render a component.
Nice.
Now, here is where things get kind of rather super interesting, because notice that we only downloaded the handler and the framework and nothing else, right? The
Yeah.
framework was able to go and increment this value, right? Like it was able to update this value in a DOM. And it was able to do that without even downloading this child component that actually has the count.
Mhm. That's smart.
And I think that's rather cool because, in this particular case, right, we have downloaded the absolute bare minimum amount of code necessary to make this page work, right? It doesn't matter how complicated the page is. Now, in this particular case, it's very simple. It's just a incrementer, right?
Mhm.
But we were very surgical about the code that actually got downloaded to the client, and we didn't really download anything else associated with it, even though there are many other components, right? If you look at it, there is a component here, there is the component here, and obviously, as I pointed out to you, like, there are many other components inside of this application, but really the only code that downloaded was the handler and nothing else.
Nice. That's super cool. Like I'm still thinking,
Right.
yeah, go ahead.
And I was just gonna say, like, I think that's the differentiating factor between Qwik and any other framework, because all other frameworks basically download all of the code at the very, very beginning.
Yeah, it actually does make a whole lot of sense because I see you sort of like let's use the analogy of you have this big HTML page. So the HTML page is your entire scripts and your components, and in there we have IDs of sections that are interactive. So
Hmm.
when we want, like when you click on the alert, you just fetch that function with the identifier
Hmm.
and you send it to the client, which lets the alert button to be interactive at the time when we need it. That makes a whole lot of sense.
That's right.
So obviously
That's right.
that's an oversimplification of what Qwik does, but that's one way I could think about it. That's great.
Yeah, it is. Anyway, it is an oversimplification, but I think it's an important understanding of what actually is happening.
Mm-hmm.
So I'm going to show you now our homepage because I think it's a good example of what's actually happening on a page. And there is a search box right here, and this search box has a listener. Where is the listener? It's right here, right here. See this button here?
Mm-hmm.
It says on click, and notice this is a production, so the URLs are much shorter in here.
Yeah.
But basically, this is showing us what's the URL and what is the thing over here. And if I go to the network, let me just refresh this again. No JavaScript, right,
Yeah.
is on the client. So you navigate to the page. This is just pure HTML, and nothing is there. And so the people might say like, yeah, but like what happens on a slow network, right? So let's
Okay.
click on this button and see what happens. When I click on this button, notice that all of the responses came from the service worker. So even if this would be a slow network, the service worker, the moment I navigated to the web page, the service worker started downloading all of these chunks basically, and getting ready for the fact that the user might click here. But these chunks really only represent the listener for here and the thing that can render the component. It didn't download this whole page. This whole page is essentially static, and so the
Yeah.
framework was like, I'm not going to bother downloading it. Like it's unnecessary. Like I don't need it, right? And so you can go to the application tab and you can see that we have service worker, and that's the party town. And so this is our service worker right here. And this service worker, and let me look at it, actually has this information about all the bundles. It's kind of encoded, but basically you can see that the service worker knows about all the possible bundles in a system and all the symbols and kind of the graph of things that the user could potentially do.
Yeah.
And all of this information is used to where's the application again? Here we go. Is used to fill up this cache. So the service worker goes and says, I know all the possible things you could do. And it goes and downloads these 6 pieces of JavaScript because it says, like, it is possible that you as a user can interact with the page in these possible ways. And if you do, you're going to need this JavaScript. And so the service worker goes and starts downloading it immediately, but nothing's being executed, right? Like we're not paying any cost. And also all of this JavaScript is running on a um, separate thread, right?
Yeah.
So the short of it is, like, this is how we make sure that the experience is fast even on slow networks, right? It is by uh, telling the service worker what to prefetch. We also can prioritize the order of prefetching. So we can basically say these things are more important than these other ones. So for example, we could, for example, say like this might be the framework. Make sure you get the framework first, and this might be the search button because most people click on a search button, and this thing on the bottom might be the logout button, and nobody ever clicks on the logout button. So like just do the last thing in the list or something of that sort.
Yeah.
So we can observe how the users actually use the application, and based on that, we can give this information to the service worker, and the service worker can go and prefetch all this information so that everything is downloaded as soon as possible. And of course, we're downloading way less code than the equivalent full application for this particular page. And the end result of all that stuff is that we can get the application up and running essentially instantly.
Hmm. Cool. So yeah, I have a question. So actually two questions. The first one is the service worker part of Qwik. Is it like is Qwik heavily dependent on service worker for the downloading of the necessary chunks of code?
I wouldn't say heavily dependent. Like it is
Mm,
a strategy that we currently use, right?
mhm.
But you could use other strategies. We can tell the system to just insert extra link href tags that tell the browser to start prefetching. You can execute the code of the service worker in the main thread. There are many options that you have to kind of deal with it. I think the thing to understand is existing frameworks just don't give you any options, right? There's really only one way to kind of work with existing code bases.
Yeah.
The thing with Qwik is that because we know how to break up your application to small chunks, and because it's important to prefetch them, you could choose your own strategy for prefetching it. You could, if you think you could do better than this, then you can certainly design something that would do a better job. Um, but I think that the point to kind of again make is that other systems just don't even to do that, right? With other systems, you'll get a single large JavaScript file that you have to download eagerly and you have to execute eagerly. And that those two pieces, the fact that you have to download and execute it eagerly, pretty much dictate that you can't do anything special with them. You just have to download it and you have to execute it. So that's that, right?
Yeah. Cool. So my second question is, how much control does Quick have? Okay, so if we're using the service worker strategy for now, how much control does Quick have in setting up the service worker, or is it up to the developer to set up the service worker, how to know what script to run
Yeah, so
first or
that's the
what?
best part, I
Yeah,
think.
yeah.
I think that's the best part. It is just how Quick works, and so as a
Oh,
developer, you don't have to do anything special. It's
nice.
just part of it. And so, as a like our philosophy is that as a developer, you should worry about building your application, not about worrying about lazy loading and chunking and all these other things. And so, if you if you go here and look at the source code, it's pretty normal code. Like this is the code that you would expect. Like there's nothing really magical in here. Like if you know React, you look at this and you go like, this looks just like React, and that's kind of the point. Is that you just write your application the way you're used to, and yet Quick can do this magic of breaking things up and making sure that nothing gets executed. And as a developer, you don't have to think about where to put lazy loaded boundaries. You don't have to think about what's the best way of prefetching it or downloading it or any of that stuff. It's just out of the box, just how the system works.
Nice. I definitely like that because I know I wouldn't want trust myself to set it up properly if I have to set up the service worker. So the fact that Quick take care of that really, really makes sense for DX.
Yes.
Mm.
I just wanted to actually show you what happens if you run a performance on
Okay.
our homepage.
Mm-hmm.
And the thing I want to point out is 29 milliseconds is the total amount of JavaScript that executed on this particular page, which is ridiculously low. If you go to most pages, you will find this in the range of seconds, not in the range of milliseconds. And actually, if you kind of zoom into it even further, you realize that almost all of it actually came from Party Town. So the Party Town is kind of where most of the, let's see, can I, nope, that doesn't work. Is where all of the kind of behavior came from. All of this other code is, has nothing to do with Quick. It's about offloading the work off of the main thread even further. So the numbers you're looking for here are very very small, and I think this is kind of the value add of the system.
Nice.
Here we go.
That's
That's the main thread, right? So 27 milliseconds. That's ridiculously cheap in terms of what normally happens. And actually, I can show you a more. Oops. All right, I'll try this again.
okay.
So I can show you kind of. We have two pages. One is this is our homepage for Builder. This is our quick page, and this is our page that just happened to be built using Next.js.
Okay.
And I just want to kind of compare this performances to kind of just give you an idea. So let me just do execution here. Give it a few seconds to kind of see what's happening. And I'm going to do the same thing on this page and performance and give this a few seconds to execute. And then let's compare the amount of JavaScript that was executed in this particular cases. So here, what you see is this huge chunk of yellow right here.
Mm-hmm.
This is hydration running, right? This here. And it looks like the hydration took 1 second on my device. So it took a second for all of the JavaScript basically to execute. Not to mention that all this JavaScript had to be downloaded before I could even execute it, and so
Mhm.
on. And so, the page really wasn't kind of ready until like 1.5 milliseconds. And remember, this is desktop, this is super fast computer, etc. Right?
Yeah.
Now let's go look at the quick version of it. Right? So again, over a second, huge amount of yellow over here. Let's look at the quick version. Notice almost no yellow here.
Mm.
uh, Page was ready about 1.5 milliseconds, 1.5 seconds. Page is ready like about 1 second over here.
Mhm.
And uh, notice the amount of JavaScript that executed, 88 milliseconds
Yeah.
versus 1000 milliseconds.
Yeah.
Huge differences, right?
Yeah.
And this is why this page is essentially instant, right?
Mhm.
Because there is really nothing to do here. You show the page and you're ready to go.
Wow. It's that's a whole lot of difference between the two. And
Yeah.
yeah, it really shows the overhead of hydration because now that we're talking about it, I'm thinking that's a whole lot of work to download all those JavaScript that the, we might not even need really. But
Yeah,
yeah.
so you can see that here. Actually, that's a good point. Let me zoom out this a little bit here. So this is quick, right? You
Mhm.
can see the JavaScript running here, and you can see there's like many small chunks here. These are actually coming from third-party scripts through Partytown, which we haven't talked about.
Mhm.
But overall, this doesn't look very busy. It's plenty of breaks for the system to do its magic, and so it's kind of a normal use of the CPU. Let's look at the React version. And what you see here is that you have these humongous
Yep.
um, chunk that's just here, and this chunk alone was 300 milliseconds, just grinding the system to a halt while React kind of did its magic. Whereas if you compare this here, you realize no such thing exists. The biggest chunk that we have is, let's see, 8 milliseconds, maybe 15 milliseconds, but other than that, like, there's nothing here that even remotely approaches this humongous
Mhm.
362 millisecond task.
Yeah. Cool. That's like that's a significant gain in terms of how much JavaScript we're shipping at the time of loading a page. Really makes a whole lot
Hmm.
of sense. So,
Yes.
you've mentioned party time quite a number of times. So, how does this fit in without party town and with party town?
Yeah.
Mm.
So Partytown
Mhm.
is so Qwik is for the code that you write as a developer, right? So the first party code is written by, or rather, let me back up a second.
Okay.
The name of the game, right? The goal that we're trying to achieve here is to put as little JavaScript on the main thread as possible,
Okay.
right? The less JavaScript you send to the main thread, the faster the startup performance is going to be, right? It's
Mhm.
that simple,
Yeah.
right? So anything you can do to offload JavaScript from the main thread is going to be a win. Now,
Hmm.
JavaScript comes to the main thread from two sources. Either you as a developer put it there because you wrote it,
Hmm.
right?
Yeah.
Or you added it as a third party code like Google Tag Manager, HubSpot, Analytics, Facebook Pixel, and so on, right? So
Hmm.
you either added a third party code or you wrote the code yourself. So Qwik is all about offloading the first party code problem, right? And Partytown is about offloading the third party. So Partytown is about taking your Google Analytics, your Facebook Pixel, your HubSpot, and putting it inside of the web worker.
Mm.
Okay, and together when you combine them, right? Qwik does amazing stuff for your first party code, and Partytown does amazing stuff for your third party code. And so the end result is that you go from 1 second on a desktop to um, 90 milliseconds on desktop. And the other thing we talked about is Google page speed, and so we can kind of look at it in builder.io. So let's look at it in the page speed score and look at it in two different ways. And what you'll see is that, first of all, these are the core web vitals. This is the information as provided to us. Um, and I'm not sure actually why this is kind of slower. I have to look into it. They shouldn't be this slow. It should be in the green. Let me
Yeah.
actually refresh it. Maybe this was a fluke. Oh no, it's giving the caching this. Anyways, compared to um, the 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 Next.js, if you give it a few seconds, it's going to come up, which is going to have a significantly worse performance on mobile, right?
Oh my God.
So notice time to interactive 11 seconds on a mobile, total blocking time 4 seconds on mobile device, right? Versus I'm not, again, this should have been better numbers. I don't know what's going on. I will have to look into it.
Hmm.
Versus 340 milliseconds blocking time. Like not the best, but
Okay.
certainly like way lower than 4 seconds in the other
Yeah.
situation.
Y-
I'm really puzzled actually why this is so
mm,
low. It should be higher.
yeah. Probably. Let's. Should I run it on my end? But
You can if you want, but I don't think it's important. Like you get the
okay.
point, right? The
Yeah.
point is
Definitely
that
get the point.
there we go. Now we get proper numbers. I don't know what
Uh,
happened with that one. It seems to be a fluke. Right.
yeah.
This is kind of normally what you would get is that 150 milliseconds blocking time, and essentially all these numbers are all in the green. Um, and so, yeah, you just get a better experience as a developer because you can faster get to what you need to get to.
Yeah. Even on my end, I have 98 performance score.
Okay.
Yeah.
Hmm.
And time to interactive was 1.2 second.
Okay.
Yeah, and the speed index was one.
Are you
The
doing
yeah,
desktop or mobile?
mobile.
Mobile. Okay. Yeah. Because
Yeah.
a lot of websites claim how fantastic they are on desktop, but really
Yeah.
it's the mobile,
Yeah.
right, that you really want.
Ye-
Uh,
Yeah,
yeah.
that's it. It's amazing. It's really good. And I have great numbers on the total blocking time, which is 20 ms for me. So
Yeah.
it's amazing because I have been sort of preparing a talk, which is, do you really need all that JavaScript? Because I, I think since last year I've been puzzled at how many JavaScript we're shipping to the browser, and I
Hmm.
like JavaScript, but at the end of the day, the I know for a fact that the more JavaScript you ship, the you are hurting the performance of the application and your users interaction of the website, because I have seen it a couple of times when critical applications on the web, like maybe a banking site or travel websites, and you load the page, it takes like what, 4 seconds to come up, and even when it's up, you can't really do anything because some things are still going on in the background. They, you can't book maybe a flight or something for a while. So all this stuff, the culprit is JavaScript, of course,
Hmm.
but it's not JavaScript in the sense of the language. It's JavaScript in the sense of the bundle you are shipping and the bundle you are trying to execute on the web page. So this make
Yes,
a whole lot of
absolutely.
sense.
And I want to really point out the fact that like when you build an application, right? Like you really
Mhm.
start with a small amount of JavaScript and over time you just adding more and more and more. And so what might start to be like a reasonable performance over time just degrades
Mhm.
because you add more and more stuff to it. And that's just the nature of things. And the point I'm trying to make here is that it shouldn't be the responsibility of the developer to kind of figure out how to not download JavaScript. It just should be how the system works, right?
Yeah.
And so the big difference between React and Qwik is that, or not just React, but really any of the existing frameworks, including
Mhm.
Angular, Svelte, Vue, etc., is that they make it a your problem. Like at some point, you're going to get big, and they basically say, "Not my problem. You deal
Yeah.
with it."
Yeah.
and and they don't really give you any tools to deal with it. Like there are no tools. Like they say like, oh, why don't you just do lazy loading? Haha. Except that lazy loading only works for components that are not in the render tree, right?
Mhm.
If a component is in the render tree and it's lazy loaded, guess what? The hydration will force you to download that component eagerly.
Oh my.
So really, lazy loading is only useful for components that are not in the current render tree, and so they make it not their problem. They blame the developer for kind of messing up,
Mhm.
and the developer has no good mechanisms by which to kind of fix this because of just how the system works. Because in order for the framework to work, it has to execute the application so that it can recover the state of the system, so that it can reason about what to do next. And the only way to do that is to download all of the code and execute it. And so this is where the magic of Qwik comes in and says, you know what? It is not your problem. You don't have to worry about it. We will just do the right thing out of the box without you having to worry about anything.
Interesting. Yeah. So okay. So like I want to go off a little tangent, not a big tangent, because we have compared with standard hydration. So one of the newest shipless JavaScript framework is Astro,
Mhm.
and I did a rebuild of my website on Astro, and the entire philosophy of Astro is HTML by default. Then we do islands, right? So
Mhm.
wherever is interactive on your page, we get to make those like we get to give those pages their JavaScript. So how does Qwik sort of compare in terms of this resumability of Qwik and island of Astro? Do they solve the same problem differently? And
Yeah, let's,
yeah,
you know what? I have a perfect demo just for
okay,
you.
okay,
So here is how regular systems work. So pick your favorite framework, right?
yeah,
And the way this works is you SSR, and then the browser has to download the JavaScript,
mm-hmm.
and then it has to hydrate, execute the JavaScript, and do the reconciliation process, right? So it has to do hydration, and so you can see how like the components become kind of interactive. What do we mean by interactive? Really, we attach listeners to them, right? And now you can interact with it.
Yeah,
So now somebody says, like, I know, let's just do lazy load things, right? So if you start with the same thing, you download the JavaScript, you start hydrating, but you come across a lazy loaded boundary.
mm-hmm.
Well, guess what? You do anything. And so the framework just has to go and download the lazy components because they're visible. There's no
Yeah.
choice. And it has to hydrate them. And so all this lazy loading you think you were getting here doesn't actually work,
Oh my God.
right?
Yeah.
So then comes Astro with islands. And
Mm-hmm.
Astro says, you know what? I know we won't do anything. And it's when you click, we hydrate all the parts.
Mm-hmm.
And when you click here, we hydrate these parts, and so on and so forth.
Mm.
Uh, and the problem here is that we're still hydrating, except instead of doing the hydration for the whole page, we have now broken the problem into smaller chunks. And so each chunk is cheaper to hydrate. So it's not like the problem has gone away. We just uh, cleverly moved it around. You're still going to have to do it at some point, just not at the very, very beginning, right?
Okay.
Now, certainly an improvement. It is an improvement because you don't have to do all of it at once. You know, it's better to pay 200 milliseconds rather than 1000 milliseconds for the hydration, right?
Mm-hmm.
And so it certainly is an improvement to the situation at hand, but it doesn't fundamentally solve anything. You still have to do hydration at some point, and now you have a new problem. And a new problem is how do you communicate between islands, because these inter-island communication becomes really a problem because all these islands are separate applications, and so all of a sudden you can't use standard mechanism by communicating between components because this component can't talk to this component because, well, it's a separate application.
Oh.
So the way Qwik is different is that you start with nothing, and let's say I go and I interact with this component, right? So this component wakes up, but notice what didn't wake up: the parents or the children, right? It
Mm.
is extremely surgical, like only that particular thing woke up that I needed to do. And second thing, let's say I interact with one of these components. Notice what happens over here, I think. No, where is it? Oh, yeah. I interacted here, and it was smart enough to understand, like, oh, yeah, but you actually need to now wake up this other component because your interaction here invalidated this component. Or
Mm.
let's say this is an add to shopping cart button. If I click here, now it goes and updates this thing over here because it understands relationships between stuff, and it knows how to surgically wake up different things around
Mm.
in this particular way.
Oh
And
my.
so Qwik fundamentally does not have resumability, right? Like, sorry, it does not have hydration.
Yeah.
It has resumability. And resumability is not like hydration done later. It's just no hydration. Like there is no hydration to talk of or to do anything with.
Mm. Mm. That's it's sort of let's say magical, but I
Mhm.
understand what's happening. So unlike other framework, even if Astro is using Island, if I have a shopping cart component and there's a button in there that maybe does something that is not related to really the shopping cart action. In Astro, so far I interacted with the shopping cart, everything will be hydrated. But with Qwik,
That's
it's
right.
just the parts that I'm interacting with and any other um so it knows how to say, okay, if I click this button, this view is going to be rendered. So also do the same thing for that view. It's crazy.
Yeah, and I really
Yeah.
want to point out is like Quick does not do hydration, right? Like in
Okay.
all these other systems, we still have to do hydration. We are just really arguing about when the hydration happens, right?
Mm-hmm.
With Quick, there is no hydration. Like there is no, because hydration is the act of recovering the state of the system and attaching listeners, right?
Yeah.
And you don't attach listeners because, well, they're just already inside the HTML as part of an attribute. So there's nothing to do to attach the listeners,
Hmm. Interesting.
right?
Yeah.
Again,
Yeah.
if we go back to our counter example, right? No JavaScript executed at this point, right? Like
Yeah.
net nothing, and yet I can interact with the button,
Yes, you can.
right? There was no hydration that had to make it so that the button becomes interactive. Like no, the button just was interactive because when a server rendered it, it put a uh, an attribute on it, right?
Mm-hmm.
That's what interactive.
Yeah.
So the moment this button shows up in the UI is the moment you can click on it, because as soon as it's rendered, it has the attribute. I can click on it and the system knows what to do because there is a URL to go fetch and perform an action on.
Interesting. So we are at time, and my mind is blown by the mind shift that has to do with not hydration but
Mhm.
resuming and having the metadata or the, let's say, the information that the page needs to be interactive in the HTML. It makes a whole lot of sense. Yeah.
It
So
does, yes.
yeah, my wrapping up question is um so obviously website that would benefit a whole lot from Quick would be like e-commerce websites or most websites that have to do with the page need to load fast and be useful
Yeah.
immediately. Yeah. So
I
do
think
you
any
have? Yeah.
site where
Go ahead.
where you need a fast interaction, like um it doesn't just have to be e-commerce website. Like suppose you are working with your coworkers and you constantly have to share URLs to like different status of tickets or something like that. Like
Yes.
how annoying it is that every time you click on a ticket it takes forever to load. Like wouldn't it be better if like you clicking on a ticket would just essentially be instant?
Mm-hmm. Yeah. It's actually thinking about it. Every web app or website should have
Yeah.
this. Yeah. So yeah, it's a it's a all use case kind of scenario, which makes a whole lot of sense. Yeah, I
Yeah, I
like
mean,
it.
I go to my bank. I want to see my bank information. I want to log in. Like, wouldn't it be nicer if all these individual interactions would just be essentially instant?
It will definitely will be. That's amazing. So we time, like I said. So um I really love this talk. I wanted to go on, but let's cap it at an hour. And yeah, I've really learned quite a lot on Quick and the mental model of it because, like I always say, it's good to have different approaches, and all
Hmm.
these research and innovation tend to move the web forward a whole lot quicker. Should I say pun
Hmm.
intended? But yes. Yeah. So no, it's really really great, and I really like it. So do you have anything you want to plug? First of all, starting with where we could reach you, because maybe folks seeing this video they wanna, this is interesting. Can I talk to Mishko? Where can I reach out? Yeah.
Twitter, M Hevery on Twitter is a good
Okay.
place to go. Um, we want to make the web faster. Is really what we care about. And on the end of the day, we want to do that because many of our customers are customers that are e-commerce customers or customers that where the speed matters.
Mm-hmm.
And so what Builder actually does is a headless visual CMS system. So if you have a need for a CMS, maybe you should check out Builder.
Yeah. Sure thing. I'll definitely do. I'll definitely do. Like I have plans to start my diving into Qwik and Party Town with just having my so I use Fathom um analytics on my website for,
Mhm.
yeah. So I could have that in Party Town and just see how that works and how that make the difference. So really, really nice to have you here, Mishko. It was really an awesome session.
Thanks for having me.
Yeah,
Thanks
sure
for having
thing.
me.
Sure.